All right, here's the bottom of page 2. So we're just talking about the radius and center of the equation, and the radius is going to be the square root of our 16. So the square root of 16, which is 4, is going to be our radius, and the center is our h and k. So remember, h is the one that goes with the x, and k is the one that goes with the y. But the equation for the formula for a circle is x minus h squared plus y minus k squared equals r squared. So because the formula has the minus in it, that means that when we plugged in h, what we plugged in was a positive 4. So the center here is a positive 4. When I plugged in k, what I plugged in was a negative 1, because a negative and a negative turn together to make a positive, so this is a positive 1. When I go to the second part of this question and I write in the equation of the circle, I'm going to write x minus negative 2 quantity squared plus y minus 5 quantity squared equals 7 squared. Now when I simplify, that minus minus is going to become a plus, so x plus 2 quantity squared y minus 5 quantity squared is equal to 7 squared, which is 49. Okay, so I did change this before, after I had printed this on number 18. This is the second page of the review, and originally your question here said, instead of 7 centimeters, it said 14, because I had biffed it when I was making the review and I forgot to divide that part by 2. And so I've changed it to 7. So we're going to go with the premise that yours is 14. So the chord is 48 centimeters long. So this whole chord is 48 centimeters long. And we know it is 14 centimeters from the center. So this guy is 14. Now remember, when I'm talking about distance, that means that it's a right angle. It also means it bisects this. Now what I'm asked to find is the radius. So while I could draw the radius in pretty much wherever I want, it's most helpful if I connect the vertex or the end point of that chord in the center of the circle, thus creating a beautiful right triangle. And since we just had a whole unit on right triangles, you know several ways to solve for the missing side. This leg right here that I just drew in, this is 24 because it's half of the 48. Remember that distance, this guy bisects the chord, making it 24 and 24. So then I'm going to do 14 squared plus 24 squared is equal to my radius squared. I'm going to plug all that into my Desmos calculator or into my handheld calculator. And that gives me 772 equals r squared. And then I take the square root of both sides, and the square root of 772 is 27.78, which rounds to 28.8. Now on the test, it should be a whole number, assuming I've made it correctly. And so you shouldn't have that problem, but if you do, it should round to the nearest tenth. On number 19, it says find the measure of BRD. So BRD is here, this angle right here. So I know it's equal to the arc. So I need to figure out the arc. Well, I don't have that arc, but I do have this one, which is 297. So I know in a circle all the way around 297, it should be 360. So I do 360 minus 297. That gives me 63 degrees. So this guy is 63 degrees. So this guy is also 63 degrees. Central angles are equivalent to the measure of the arc they subtend. On number 20, looking at arc. This guy is supposed to be an arc symbol. So I'm looking at arc WY, and I know that WY is 12x plus 10, and then angle W, let me change that guy, WZY over here is 7x. So what we talked about in fourth hour was that when we're trying to solve these problems and we get confused about the rules of what goes where, think about if this problem were real numbers. So let's forget that we have variables at all. Let's say this were 120. Well, we know this angle is half of the arc, so that would be 60. Or vice versa. Let's say we're given the 60. That means we would double it to get 120. So now that we kind of remember our rule, go back and look at this. I can either double this guy and they're equal, or I can take half of this guy and make them equal. Either way, I have to double the angle or half the arc in order for them to be equivalent. Likely you would prefer to make this doubled. So 12x plus 10 equals 2 times 7x. So 12x plus 10 equals 14x. Subtract 12x, 10 equals 2x. So 5 is equal to x, and I can stop right there. Last two on this page on this video. The fact that I am given that this angle is 39 is completely arbitrary. I don't actually need that information at all. What I do need to know is that this is the diameter, which means that this is half of the circle. And half of the circle is equal to 180 degrees. So 180 degrees is the arc that this angle right here subtends. So that means that this angle is half of that 180, which is 90 degrees. Now, in general, whenever I inscribe an angle inside of a semicircle, it will always be 90 degrees because the arc it intersects will always be a 90-degree angle. So, or it will always be 180. So it doesn't matter what I do here. I can draw this any number of ways as long as it's an inscribed angle. The arc is always 180, so the angle is always half, which is 90. All right, last one on this page. This one should be a fairly simple problem. We are just finding the measure of this angle. So it's inside the circle. The vertex is inside the circle, so it's half of the sum. So 1/2 the sum of the arcs. So this arc and this arc. So 1/2 of 34 plus 42 is 1/2 of 76. So that is 38 degrees. All right, I'll make one more video for our last page.